In the last video, I told you I would show you how the variable frequency drive works on my small Grizzly mill. First, we turn it on by flipping this circuit breaker. I'm actually using the controller remotely, using an extension wire. I can take it from the VFD over in the cabinet and actually mount it right here. This flashing that you're seeing is only showing up in the camera. In real life, that is not happening. So to show you how this works, I'm going to open the top so that we can see the belts spinning. You get an idea of how it's working. But it's simply a matter of adjusting the frequency. You don't adjust the RPMs, you adjust the frequency. And right now it's at 47 hertz or 26 hertz or whatever it is. To start the motor running, you simply press run. And as you can see, the motor is running. If you want it to go faster, you just turn up the frequency. Now this is all programmable too. I can make it run so fast that it's too fast for the bearings in this small milling machine. The beauty of it though is as the machine is running, you can simply immediately reverse it. You don't have to go through stop. Forward and reverse. This is the beauty of a three-phase motor. There's also many other things. There's over 135 different modifications that can be done through the VFD. It's really quite incredible. And to be totally honest, I don't understand all of it right now. But here's the big problem that I talked about. Now that is my digital readout. And what that does is as I'm cranking different controls over here, it's showing me where the axis is. And that's all well and good, but let's say I'm starting a machining process and for whatever reason I need to be at 0.75. So we bring this up to 0.75 and then my y-axis needs to be at, let's say, 0.065. So I'm all set. I'm ready to start doing some machining. And I turn on the variable drive. And as you can see, everything just goes blank. Now that flashing of the DRO is actually flashing. That is not the camera. But I've lost all my controls. It just goes crazy. And I don't know if that's damaging to the DRO, so I'm going to shut it off. I've ordered filters. I've ordered an actual filtering device that's designed for this type of a situation. And then I ordered what is called ferrite iron core chokes. And I will be putting them on the input lead to the VFD and on the output. And that should solve this problem that I'm having. But other than that, it really is fantastic. I love it. I love the ability to, as I am actually cutting a piece of material on the machine, I can change the speed. And I can watch the finish that I'm getting on the material. And even going this slow, I'll put some light on the situation so you can see it. It is totally impossible to stop. Now that other motor is 1.5 horsepower. I could stop that motor if I had it on the slower speed by hand. I can't stop this motor. And that thing's running, I don't know, that looks like what, about maybe 30 RPM, 50 RPM? At some point I'll sit down and I'll be calculating what 11.5 hertz is in RPMs on this machine. We'll figure that all out. I still have use of the belt change. So if I want to make this thing go real fast or even slower, I can, but I don't see any reason for it. In fact, I'm actually thinking about removing that idler pulley in the middle and just driving one big belt from the motor all the way to the main pulley. Although having two belts, it does remove vibration. That motor has a certain amount of vibration, and the dual belts will get rid of it. And as I feel over here on the milling machine, there's just about no vibration. Yet over here on the motor, there's a certain amount of vibration. So those belts are filtering the vibration. And that vibration shows up on the finish of the milling on the metal when you're doing some finish work. Anyways, that's where we're at. With the VFD conversion of the Grizzly mill. More to come as we get this DRO to work. Thanks for watching.